So here we have a road problem. And the thing about road problems in geometry or trigonometry, it's always worth doing a sketch. You know, they always say a picture is worth 1,000 words. So diagram is very important. Let's see if we can do a sketch of the situation here. The top of a 13-meter long ladder is leaning against the top of a 12 meters high wall. How far is the foot of the ladder from the wall? So let me draw the wall first. So the wall is 13 meters high. Alright. The wall is 13 meters high. So let's say I have a wall. Let's sketch here. So we have a wall. Alright, and the wall, this is the wall, right? And the wall is 12 meters high, well, from the ground. We're assuming it's 30 meters from the ground. 12 meters from the ground, of course. Here's the ground, yes. Here's the ground, the green grass here, here's the ground. Alright, so this is the ground. On the wall, 12 meters high. The ladder is the top of the ladder is leaning against the top of the wall, alright? So here's the ladder. And this is meant to be a straight line. So the top of the ladder, here's the top of the ladder, is leaning against the top of the wall. So so top of ladder, top of wall coincides right here. And this is the foot of the ladder. So here's the ladder. Leaning against the wall, top of the ladder, top of the wall. Here's the foot of the ladder. And how long is the ladder? The ladder is 13 meters long. And we're asked how far is the foot of the ladder from the wall. So here's the foot of the ladder, and here's the wall, so I guess they're asking us for this distance. So we're asked to find this distance. The foot of the ladder to the wall, this distance. And let's call it x. And what you realize there is that we have a Pythagorean situation here, where the angle, we assume it's a straight wall, a vertical wall. And the angle between the wall and the ground is 90 degrees. So we can assume it's a vertical wall, right? And so we can apply Pythagoras theorem, which says the hypotenuse square, the ladder would behave as a hypotenuse in this situation here, because it's opposite to the right angle triangle. So this distance, ft, the ladder, 13, so 13 square would be equal to the sum of squares of the other two sides. So this side, so 12 square, and this side here of the triangle, we don't know what it is, that's what we're trying to find, we'll call it x, so x square. So 13 square, that's 169, 12 square, that's 144, and we need to isolate the x square. Good. So we can subtract 144 from both sides. So we take 144 from this side of the equation. So we're left with nothing. We'll accept the x squared, that is. And we take 144 also from the other side. If you want to say, we group the 144 with the 169, so it becomes negative here. So 169 minus 144, that's 25. So So x squared equal to 25. And then we take the square root of both sides. So x squared equal to 25. What number do you multiply by itself to get 25? And that is 5. So x is 5. Which means that the distance from the foot of the ladder to the wall is actually 5 meters.